Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Scott.
And I'm Hudson. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@kern.org. We're online at dothemathonline.net and on social media.
Thank you, Hudson. And what grade are you in?
5th grade.
5th grade. At what school?
Del Rio Elementary.
And it's the Del Rio. Are they dragons, dolphins?
Dolphins.
Oh, I was just kind of guessing. I wasn't sure. I know like downtown elementary is close to here.
Yeah.
And I think they're dragons. So that's why I kind of came up
more
with
than
that
you
one
thought
first. But I was trying to think of other D animals or whatever. So how do you like 5th grade?
5th grade is fun.
Yeah. Is there any particular part of 5th grade that you like more than others? Like a topic or subject, something like that? Any activities you do different or something?
I like the social studies. What we're learning about now is interesting.
Is it American history in 5th grade?
It's like the Revolutionary War.
Okay, yeah, so American history, right? So
Yeah.
you've got the Revolutionary War going on right now. So that is pretty interesting stuff because when I taught 5th grade, that was one of my favorite parts of teaching 5th grade, was learning about the American Revolution and all of the different things behind it and what started it and then how it went on and, you know, eventually like that. So I'm glad that you're enjoying that right there. I know that you and Sophia were speaking a little bit before we went on show today, and she had said, what is your favorite number? So what is your favorite number?
Pi.
So can you tell us a few digits of that?
3.14159.
That's pretty good right there. Now, why is pi your favorite number? Because most kids just go like 7 or 18 or 23. 23 is a lot, it's a big one right there, but pi is an unusual one. So why is pi your favorite number?
I just like it because it's like the longest number in the world.
Yeah, I mean, there's like
Infinite.
Like, I mean, yeah, the thing doesn't end, right? I mean, they have some computers working for years trying to find digits and digits and digits to this thing. So have you ever entered a contest to see how long you can recite all of those numbers?
No.
Yeah, see, I don't know about those things. You know, it's like, all right, great. So you memorized a bunch of numbers for a long way. What's it going to do for you, right? I mean, but anyway, I'm glad you like pi. Do you do pi activities in school? Have you done those at all yet?
No. No pi activities in school.
In 4th grade, they didn't have pi day for you?
We do have pi day, but I think we just did one activity, and then we got mini pies.
You got a mini pie?
Yeah.
What kind?
Cherry.
Cherry pie. Oh, I like cherry pie. They didn't give you like, you see, when I grew up in New York, we would call it a pie. You guys call it a pizza. Would you like a pizza instead of a cherry pie?
I don't know.
Because that's a pie too, right?
Yeah.
So now you know it's a pie, right? All right, good. Well, I'm glad everything's going well in 5th grade. You ready to help me out today?
Yeah.
All right, we have a social media problem of the day we need to look at, so here it is right now. So what is the equivalent fraction? Do you know what equivalent fractions mean?
Yeah.
What does that mean?
It means when it's equal to the fraction, like
Okay.
basically two fractions are
And
equal.
what is the fraction we're looking at first?
4/10.
All right. And taking a look at the options up there, which one do you think is equivalent? Let's go through them first of all. Now, A, 2/8. What do you think about that?
No, because 4 and split in half is 2,
Okay.
but 10 split in half is 5, not 8.
All right. So A seems to be out of the question right now, right?
Yeah.
All right. B is 1/5. What about that? There's the 5.
No, because there's no way that you can split 10 evenly and do the same thing to 4 and get 1.
All right. What about C?
40/20. No, because 20 is too basically small of a number, and it's not an equivalent fraction. no, sorry. It's not, it's an improper fraction. So it would actually
Correct.
be 2.
That's a good way of looking at it also, right? Because the numerator is larger on that one, right? So that's good, because a lot of kids go, well, I'll just put a 0 at the end of 4, and then they'll do the same at the bottom. But if you do it to the bottom, you're going to get 100, not 20, right? All right, so all right, we're down to D. Hopefully this one works.
8 20ths, 4 times 2 is 8, and 10 times 2 is 20. So
But you think D is the correct answer?
yes.
Do you see why they may have put the other ones up there, though?
2 8s could seem convincing. Because like,
Right, and that's what they want it to do. They want it to seem convincing to students, right? Because some students will go, well, half of 4 is 2, so I can go 2 8s. And some students will go, well, half of 10 is 5, I can go 1/5. That's why they put those up there. This is called error analysis, what you're doing right now. You want to take a look at the wrong answers and figure out why did they put those there. Does that make sense to you?
yeah,
Yeah, so there's a little something new for you today. So you're going to go with D?
yeah.
All right, let's take a look and see if indeed you are correct. There we go. 820 is correct. First problem all done. Don't see how easy that was? All right, nicely done. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Programming note, final month of this season, our 23rd season coming up next month. By the time April rolls around, no more live broadcasts, but there will still be Do the Math social media activities going on all year round. Time now for today's Math in the News. All right, today's Math in the News has to do with different types of homes, and this is a super adobe house. And I know that a lot of students, especially in California, have probably seen these types of houses and homes, especially the materials that they're used to build these with. Mostly sandbags, plaster, and then they use other earthen materials to make these houses. And these are new homes that they're building, but they've been around for hundreds and thousands of years throughout the southwestern United States. So let's take a look at it right now, and then we'll get to our math part of it also. So they're created by Cal Earth, and they're built from sandbags, barbed wire, soil, and water to create an eco-friendly space that can withstand environmental impacts. And that's why we wanted to bring this. This is Math in the News. The news is environmental impacts, especially with natural disasters that do a lot of destruction to different buildings. But you can see where they've got the sandbags, they're starting to pile those up. You've got the barbed wire helping to connect those, and then later on they apply some plaster to them to make everything uniform and stay together a little bit more. So, as we keep going. So, earthquakes and fires help to shape the structure's design. The dome is a very important part of architecture, and a lot of architecture around the world, some of the more famous ones and the older ones, are created with domes and arches because those are very strong and can withhold a lot of weight with the arches. All right, UV resistant bags. Very important because of how much sun is going to be hitting outsides of houses, obviously, right? The barbed wire is placed between as reinforcement, as I said a little bit earlier. Here is where the plaster is being added, and then that further reinforces all of the different materials to bond together. It can be built without heavy equipment because a lot of times you're going to need cranes and other things coming in. So you can do where you can actually put a building together in a day. Based on the size of the building, you're able to do that. But the big thing is resistance to flooding, fires, earthquakes, other natural disasters, and they last, I mean, as long as you're going to last, the house is going to last, all right? So these are things that are in the news recently because of housing shortages, need to develop new ways, eco-friendly ways to develop housing, and especially here in California. So moving on, taking a look at perimeter and circumference of houses. So if we have a house that most of us probably live in, it's probably pretty rectangular. So if we want to find out the perimeter of the house, we simply take the measurements and add them up. So if it's 10 feet on this side, it's also going to be 10 feet on this side. 17 up here, 17 here also. So to do the perimeter, you simply add up all four sides. So the 17 and 17 make 34. The 10 and the 10 make 20. So here we can see that the perimeter is 54 feet. That's the distance around the house. But if we want the area, then we need to take a look at the footprint, which would be 17 times 10 would be 170 square feet. So now we're going to take a look at the perimeter of a dome house, which is often called the circumference also, because now we're dealing with a circle. There are two things you need to remember about using circles and the numbers that are associated with them. So you have 2 pi. Kind of ironic that you're here today, Hudson, and we're dealing with pi, right? I had no idea your favorite number was pi until a little bit ago. 2 pi r, and r is the radius. That is to find the circumference. Then we take all of the same elements, but now we're going to go pi r squared to find the area of a circle. So you're using the same 3 pieces, but you have to rearrange them if you're doing circumference or area of a circle. So if we want to do the circumference of this circle, we know that the diameter is 10, which means the radius, which is halfway, is 5. So if we put that in here, we have 2 pi 5, so we can just manipulate the 2 and the 5. So that would be 10 pi, and it is still feet. So we can know that that would be around 30 something feet as far as the circumference goes. That is today's Math in the News. We'll be back with more right after this.
My name is Emily Duran.
And my name is Anufa Rodriguez. Today we're going to learn about place value.
Today we're going to uncover the secrets of how numbers really work. Have you ever wondered why some numbers seem so big or so small? Well, it's all about something called place value.
What's place value anyways? Imagine numbers like a team where each player has a position and a role. Place value is just like giving each player a job based on where they stand.
As you can see here, since this 3 is in the hundreds, its value is 300 because this one is over here and this one is 3.
Zeros and zeros. Sometimes we see zeros hanging out in numbers 205 or 7001. Those zeros ain't just taking up space, they're actually placeholders. They tell us there's nothing there in that place.
Big powers, big roles. You know how superheroes have powers? Well, numbers do too. But instead of flying or super strength, they have the power of 10. So, the further to the left a number is, the bigger its power of 10. The hundreds place has more power than the tens place. As you can see here, 10,000 by the power of 3 equals 10 times 10 times 10. So it's multiplying 10 by itself 3 times, which would equal 1,000.
Real life stuff. Knowing about place value isn't just for school. We use it all the time. Like when we count money or measure things, we're using place value to understand how much or how big things are.
That's it, friends. You've cracked the code of place value.
Keep exploring, keep counting, and have fun with numbers.
There we go, another nice Let's Talk Math right there. We have Hudson, a 5th grade student from Del Rio Elementary, in studio with us today. Feeling pretty good about that pi, huh? I thought that was pretty funny that pi came up in the Math in the News today. Anyway, how are you with fractions? You like them?
Yeah.
You said that that's what you're doing in class right now, right?
Yeah.
All right, come on over here with me, brother, and check out some fractions right now. All right? So head over there. I've got a riddle for you. You like doing riddles?
Yeah.
It's your big day. Here we go. So what is 3/7 chicken, 2/3 cat, and 1/2 goat? So when you see this, what do you think of? What's the first thing you're thinking of? What are you wondering? You're like, are you crazy, old man? I don't know, with these different animals up here.
I don't really.
Kind of a tough one, isn't it?
Yeah.
That's why it's a riddle. All right. So what can you tell me about the fractions right now? Do you know anything about them? Do you wonder anything about them?
Wonder if there's a way to make them all equivalent.
Okay, that's funny you talk equivalent because that's what we were doing earlier, right? Equivalent fractions. We're not going to deal with the equivalency thing today, all right?
Okay.
So, which one of the fractions do you think would be the easiest to work with? 3/7, 2/3, or 1/2?
1/2.
1/2, right? I'm glad you said that because 1/2 would be the easiest. We just take something and break it into 2. right? If we have goat and we want to break it into 2, how could we possibly break that, do you think?
You split the letters.
Okay, we could split the letters, right? How do you think we would split it?
In half.
Okay, so what would they be? What would one half be and the other half?
It would be go and at.
Right, it would be go and at. And those are actually 2 separate words, right? It just happens to work out nicely that those are separate words. So it's 1/2 goat. So we know we're going to have half of this, which is either going to be go or at, right? And this is at the end, so you want to keep that in mind, all right? Now what about 2/3? That seems like it would be the next easiest one to work with, right? So 2/3 cat. Now if we do the same thing as we did here, what do you think we're going to do there?
It could be CA or AT.
It could be a CA or an AT, all right? Now what about 3/7 chicken?
There could be, it could be CHI, chi. It could be kin.
A couple things it could be, right? I mean, because there's a lot of letters in there, right? So do you have any strategies how we could figure this out? Because you're on the right track as far as breaking the names up.
I would look for some that look like they could start a word.
Right, because we know this is going to be the beginning,
Yeah.
that's going to be the middle, and this is going to be the end. So what out of here do you think would be a good beginning?
I think CHI.
All right, so we're going to go with that. All right, now what about the 2/3 cat? So we have CHI, then do you want to go CA or do you want to go CHI-AT?
CA.
CA, right? So now we have CHI, CA. You have any idea where we're going to end up with this thing?
GO.
If we put that at the end, what would we have?
Chicago.
Chicago?
Yeah.
It would be Chicago, right? But it's the name of a place. Think about putting it all together now. CHICAGO. It's the name of a place, Midwestern United States, probably like the 3rd or 4th.
Chicago.
There you go, Chicago, right? So see, that way you just kind of reasoned through it, right? So nicely done. You got that riddle right there, all right? So now what we're going to do is we are going to make you start doing some more work with fractions, but you're going to be dividing fractions now, and to do that, we're going to have Scott give you the most difficult problem of the day so far, all right? So take it away, guys.
Let's see how that goes. All right, do you know how to multiply fractions?
Yes.
Do you? All right, let me have you do something real quick for me. So let's say, what if we have 5/4 times 1/2? How do you multiply that fraction together?
You do it straight across. So
Okay.
4 times 2 would be 8.
Yeah.
And 5 times 1 would be 5.
That's
and
it.
Can't be simplified anymore.
So you're done with that one. That was pretty quick. That works out pretty well. So what do you know about dividing fractions?
I know keep, change, flip.
Ah, there you go. And sometimes the students that I work with don't know why the keep, change, flip thing works, but they know it works, right? So I'd like to show you, before we get on to a lot of dividing fractions, why it works. Let's say we have this, right? Let's say we start off with 5/4 like we did before, but instead of multiplying times 1/2, we're going to divide this number just by the number 2. Okay, we're going to cut it right in half. No big deal there. We talked about that a little earlier. We know half is going to divide it into 2 equal pieces. How would you do this problem? You can do it right underneath here. How would you do that problem if you keep, change, flip like you were talking about?
So I would keep this number.
Okay, you kept the 5/4.
I would change that to a multiplication symbol.
Ah, so we changed the division to multiplication. All right, there's the change part. Now what about the flip part?
And-
Is 2 a fraction?
No.
Let's
so
make it into a
what
fraction,
I-
right? Every number in the world can be a fraction. So let's make this one into a fraction. How do you do that?
Add a 1.
Hold on. We're gonna change it, ready? Or flip it, right? We gotta make it into this fraction first. So the fraction we're talking about, even though it's a whole number, is actually a fraction, 2/1. Every number in the world you can make into a fraction. So now take that fraction and flip it over. Hey, look at that. And what do you get?
You get 5/8.
That's it. So do you see that this problem here that we just did, and you're telling me the answer to this is 5/8 because you keep, change, flip, right? You get 5/8 here. This problem, 5/4 divided by 2 over 1, is the same as 5/4 times 1/2. That's why keep, change, flip works. Okay, so you can see that even if we don't know the answer here, we get that same answer here. But if you change the sign and flip the second fraction, you get the same answer, which is the way it should be. Okay, so now that we know what's going on there, let's try another one. How about if we have 4/5, right? We're going to start with that one there. And we're going to divide that by 2/5. Let's see what happens there.
There you go. So you'll do that one, show Scott what to do, and then we'll move on to something else.
Sounds good.
All right?
So what would you do on this one with the same exact strategy?
So you have to keep the 4/5.
Okay.
You change it to a division sign, and you flip it to be 5/2.
Good.
You multiply 5 times 2, which equals 10, and 4 times 5, which equals 20.
Sometimes we really like to work with those multiplying fractions because you can just go straight across, right? That's super nice. All right, are you done with that one?
So Scott, before you move on, because that is your last problem right now,
Yeah.
but maybe show him how to cancel first
Right.
instead of all the way at the end.
Sure.
And maybe he already
I was
knows.
thinking we could reduce this at the end, then we can go back and see if we can make it a little bit faster too. Yeah. So what would you do if you just kept this problem exactly like you have it and you ended up with 20 over 10? What would you do for your final answer?
I would.
Because you can probably reduce that fraction, right?
Yeah.
Okay.
So both of them can be divided by 10.
Okay.
10 divided by 10 is 1.
Yeah, so you can divide by 10. We want to kind of show what's going on there. So on the bottom it's 1, on the top it's
2.
2. And we know from this one over here, you could actually make that into just a whole number of 2, right? But if we go back to this problem right here, do you know, have you ever done any cross-canceling before? Or any
Yeah.
elimination? Okay, so if you were going to go back here and not go on yet before you actually multiply them together, what could you cancel in this problem before you started multiplying?
Could turn the 5s into
Yeah, you can cancel those ones out because they both get divided by 5, right? What about the other sides?
You could turn this into 1 and turn that into 2
And why does this become 1 and that becomes 2? What's going on there?
because they can both be divided by 2.
Ah, there you go. So you kind of have to know what's going on behind the scenes, and I think you do. Now, what's 2 times 1?
2.
2, look at that. And 1 times 1?
1.
1. So we can eliminate this step here by doing a little bit of work beforehand. Either way, right, people have their own preferences. Either way, we're still getting to the same final answer. You could have 2 over 1, or you could just have 2, and they would both be acceptable.
There you go. Nicely done, boys. For your great effort so far today, you've got yourself a meal courtesy of our friends at Chick-fil-A, so congratulations on that. We'll be back with more right after this. All right, well, welcome back. And in studio with us right now, we have Noah. And how are you today?
I'm good. How about you?
Excellent. So what school do you attend?
I go to Highgate Elementary.
All right, and what grade are you in?
I'm in 6th grade.
All right, so how was 6th grade?
It's pretty good. I mean, learning some math and the usual stuff, but math's probably my favorite subject.
Why? I know you're on do the math, but I mean, if math
Yeah.
really is, I mean, what do you like about mathematics?
I like that it's algorithms. So if you master the algorithms, you'll the outcome's usually always the same, rather than ELA where you have to read it then figure out what it is. So it's just a different
Different way of thinking and looking at
different way of
things.
thinking, yeah.
All right, good. And you like that way of doing things?
Yeah.
Have you ever found that with algorithms, even though there's one and they go, this is what it is, this is how you can solve it, have you found other ways to be able to solve problems, maybe
have.
sometimes easier than the algorithm that was presented?
Yeah, I have. I've looked into Vedic mathematics, which people at home can look up, and it's just a different way of doing it. Like they use, it's going to base 10, and there's an 11 trick and stuff like that, which I think is really cool.
And there's a lot of mathematics in your hobby, right? Because
Yeah.
you like robotics and robots and things like that.
Yeah.
So first of all, I brought you in because there was a specific reason about you and what you have accomplished at such a young age.
Yeah, so I took this test, and it's right here. This is my certificate, and it's on the Universal Robot website. I'm the youngest person in the world to get this certificate, and it's something that allows you to use these things called universal robots, which are found in all my pictures here.
And that's not something just to gloss over there, all right? You are the youngest person to have achieved this.
Yes.
So what got you interested in robots and kind of going towards this goal of yours?
Well, my dad works at CTech in the robotics program, and he does a lot of stuff with robotics, which I'm going to shout out CTech and all their students.
We love CTech and everybody else.
Yeah, I see you got some stickers here. So yeah, he's a teacher there, so I'm always in this lab, and I see all the robots, and I've seen there's other stuff like the Kukas, the Boston Dynamics dogs, all that stuff.
So you've grown up with it.
Yes.
And you found an interest in it, and you kind of pursued it, and now you're well on your way.
Yeah. So in this, I was just thinking about how can I use these universal robots, which are just like arms. How can I use these, or how would they be used in a fast food environment? That's why it's called culinary with robots. So it's just the burger here. It was laid into different things, right? Just say something like this, and they were all stacked, and just how that would be found if you were to go into a McDonald's.
Okay, and I know that we've got some video of this right now. So what we're going to do is we're going to take a look at the video, and then you explain to us what we're looking at right now.
So this is me stacking them, and then getting ready. Where they were all stacked first is where the build plate is going to be. This is me programming it and writing down all of my tests and what they were. This is the night class from a couple years ago. They're just watching me they're watching me and the robot do the project.
And that's you working with high school students.
Yeah.
And you're kind of showing them what you've developed and what is going on.
Yeah, so a couple years ago, or last year, I was in the night class with my dad, and he sent me with a group, so I kind of know some of them there. But they just came over to say hi, and I happened to be doing this.
Okay, so these are the different parts of the burger, right? And obviously you had to create these to show as a model.
Yeah, so I used these, which
Like the top of the bun. And
yeah, so there was the bottom bun, the patty, cheese, lettuce. I didn't do this one. But this was my second prototype. My first one could be found in some of these pictures here. I used Jenga blocks, and I used suction cups that were built for this gripper itself, or the hand of the robot. Yeah, so this is just, I used 25 experiments each, and I ranked the scores. I have my notebook in that, but it was just to see how well it would.
So you could do something like this for a science fair project.
Yes, which this is.
Okay, so this is your entry.
This is my entry, and I passed through my school Highgate.
Right.
So I'll be at the
county level.
The county level in Mechanics, or I think it's the Mechanics Bank Arena.
Right. And when is that coming up?
I think it's March 11th, I believe.
Okay, well, I know it's in March, so you're going to want to make sure you don't miss it, right? So make sure you get that exact date.
Yeah, I'll
right?
get that exact date down.
All right, and what day of the week that is? Do you know what day of the week that is?
Oh, no.
It's not a Tuesday, I hope.
Can't be a Tuesday.
Right, because that's a different class you got going on
Yeah.
Tuesdays right there. Okay. Anyway, so what is your next goal? I mean, because you probably have some goals further down the line, but maybe like your next goal while you're still kind of in school right now.
So with this,
Anything at all as far as robotics goes.
well, I'd like to be able to work into different types of, or different robots. Like this is the UR, or Universal Robot. I'd like to venture into maybe specific things in culinary or really anything that has to do with building. I'd also like to go into what I was learning in that night class. I would like to figure out or learn it's like programming. I forgot what they were called. But it's like a suitcase with a bunch of buttons.
Okay.
So it's basically like lines of code, but it's found in a different way. I'd also like to venture into KUKAs and a little bit into Boston Dynamics.
That's, you know what, I mean, you keep going, you're going to have a lot of job offers when you,
Yeah.
very soon, so.
When I'm older, I want to get into or work at this place called Boston Dynamics, and they're doing a lot of cool stuff with robots. There's a couple videos on YouTube with them dancing robots, parkour, stuff like that.
All right, now here's the deal we're going to make, all right? You ready for this? All right, you're going to come back in a couple of years. You're going to let me know how you're doing, because we had a student who I met a couple of years ago, and he's been training for the Olympics as a gymnast, and he was just on a couple of weeks ago because he kept us up to date, and he's now getting ready to hopefully make the Olympics in LA, right? So you, I know, are going to be doing a lot of things, and you agree to come back and let the old man know about how things are going?
I will.
All right, we're going to shake on it. There we go. It's on camera right now. All right. Noah, thank you very much for taking some time coming down and show us. I know a lot of students, as well as adults, very interested in what you've been doing. So thank you for taking out some time.
Before we leave, I just want to give thanks to Carlos Gonzalez. He helped me with all these projects here. My friend Julian Cremonini, I promised him I'd give him a shout out. And all of my friends, they've supported me throughout the 4 years I've known them.
Well, good. That's an awfully nice thing to do right there also. We'll be back with more right after this.
What is a black hole? Imagine a place in space where gravity is so strong that nothing, not even light, can escape its clutches. It's a region of the universe where space has collapsed in on itself to a point that has zero size. It's called the singularity. It's a point in space where the matter of an object has been crushed, basically out of existence, but the mass remains. The mass of an object is a way to describe how much stuff like atoms, molecules, and particles are in it. So, it's gone, but still there. And its gravitational field affects everything around it, and because not even light can escape, we call it a black hole. You might be thinking, how do we know black holes exist if we can't see them? Astronomers notice stars behaving in strange ways, orbiting around invisible companions. They often suspected a black hole's powerful gravity must be doing some stealthy influencing. By observing the effects of a black hole's gravity on nearby objects, they can learn a lot about these hidden cosmic giants. This shows the swirling hot gas that is getting sucked into the black hole. It's called the accretion disk. If you are in space, your eyes limit what you can see, so scientific artists make animations like this to help us have an idea of what it looks like. There are a couple ways astronomers think black holes are created. One way is when a star, more massive than our sun, runs out of fuel and explodes as a supernova. One of the possible results of this explosion is a black hole. The core of the star collapses, and much of the mass of that star collapses down into nothing, a singularity. That's where all of the crushed mass is. Black holes that are created when a star dies are known as stellar-sized black holes. Another type is called a supermassive black hole, that scientists think form when black holes collide and merge into a bigger one, kinda like when you combine small pieces of clay. Scientists believe there may be a supermassive black hole at the center of every galaxy. We know there is one at the center of our galaxy, the Milky Way. American astronomer Andrea Ghez was awarded the Nobel Prize in Physics when she discovered it after 25 years of research. It is called Sagittarius A star and is about 26,000 light-years from Earth. A team of scientists using radio telescopes from all over the world created an image of those radio waves translated into something the human eye can see, since we can't see a black hole. Black holes are made of two components, the singularity and what is called the event horizon. To learn more about the event horizon, let's ask Dr. Joe Pesch with the U.S. National Science Foundation. He's an astronomer who studies black hole formation. Dr. Pesch, can you explain what the event horizon is?
What we call a black hole is the singularity surrounded by the event horizon. The event horizon can be thought of as the last orbit outside of which material can escape, the black hole, the singularity, and inside of which material falls into the singularity. So the event horizon is a shield around the singularity, and in the universe, it's a three-dimensional structure, so it looks like a sphere. And so you have the singularity, and then the event horizon surrounds it. It looks like an ultra-black sphere. Now, if that black hole is rotating, and when they rotate, they typically rotate very rapidly, large percentages of the speed of light, you might get an oblong structure of the event horizon, so it's no longer spherical and like a globe, but it might be more elongated like a football, perhaps.
So once matter crosses over a black hole's event horizon, a sort of boundary line, it is trapped within that gravitational field and cannot return to the outside universe. The size of its event horizon depends on the mass of the black hole. The more massive it is, the larger its event horizon is. Black holes are invisible yet powerful, shaping the cosmic dance of stars and galaxies. While they may sound like something out of a science fiction story, black holes are very real, adding a touch of cosmic magic to our ever-expanding universe.
All right, we've got Hudson, a fifth grade student from Del Rio Elementary, in the studio with us. Pretty cool with the robotic stuff, huh?
Yeah.
Have you ever done robotics or done any coding or play games, that kind of stuff?
When I was younger, I just kind of checked it out, but then I kind of lost interest in it. But
No. Well, you never know. I mean, things come around again like that. It's funny how you say when I was younger. I remember those days, many, many moons ago when I was younger. Let's see, you're in fifth grade, so you got to be around 10, 11 years old?
yeah.
All right, that's more than 50 years ago for me. Anyway, I see John smiling over there. Same thing for him, too. So easy there, young stud. All right, you guys ready to get to work?
Let's see what we can do
All
here.
right, over to the board, you guys. So hit, I think it's already on annotate for you, Scott. So Hudson, you see a beginning point, an arrow up by Scott's head on the far left. And there are two places to come out of this, let's say, number maze. One is where you have a 90 and the other is a 70. So it's up to you. You can go whichever one you want to do first, but you're going to have to do both of them. And obviously some numbers are going to have to be repeated. So I would suggest maybe doing two different colors, like once you find one way, maybe do it in red, and then the next one choose another color. Now, what number do you know right now you're going to have to go over twice?
Probably 3.
Yeah, because that's the first place to go in, right? After that, you can either go to the 4 or the 3, but you must hit that 3 both times. So go ahead, start. If you need a little bit of help, Scott's right there, and you decide if you want to go for the 90 or the 70 first.
Can you tell us a little bit about what's going on?
You're going to add them as you go.
Or just adding,
Right.
so we can't use subtraction and
Oh,
multiplication.
no, son. You're just adding them up.
I was really thinking exponents might work real well on this one too, but we're just going to add. So we want to make sure that the result of the problem is 90. We can go any direction. Last question, are there any other restrictions that we have to hit a certain number of numbers or just
No.
have a result? Okay, gotcha. Okay, so where do you think you want to start? With the 3?
Yeah.
Great place to start. Okay, we got 3 so far. And are you shooting for the 90 or are you shooting for the 70?
Probably the 90.
Okay, let's shoot for this one down here. So we got to get to that 90. Now, what is the, this is interesting, I like to look at a puzzle like this sometimes. What is the number that's right before 90 that you have to go through to get to 90?
45.
45. So once you get to here, right, then you're going to have to add, or from this direction or that direction, you're going to have to add 45. Would you agree? So what's the number that we have to have either in this spot or that spot to add the 45 to get 90?
You need 45.
45, that's it. So by the time we get here, or by the time we get here, we better have 45 so we can add 45 to it. It just kind of takes one step out of the process if you want to think of it that way. It makes it a little bit easier or another way to look at it, right? So the other question that we have is which direction you want to go. Now maybe you have an idea about which direction you want to go, maybe you don't, but what do you think about at this point about which direction you want to go? Do you want to go down? Do you want to go over? You want to go down and over? What do you think?
I want to go down to the 3 and then to the 2.
Okay, gotcha. So if you're going this direction here, what's 3 plus 3?
6
Okay, so we're at 6 in this part, and then we're going to go over here. 6 plus 2?
is 8.
8. Okay, so far so good. What else do you want to do?
I want to go to the 12.
Okay, we're going to keep on going this way. What's 8 plus 12?
20.
Good for you. You want to go up?
Down.
Down. What's 20 plus 25?
45.
Hey, look at that. And so the good thing is we didn't even have to get to the 90 because we did a little work on the front end of this problem to figure out as long as you get 45 by this point, you're going to be golden. Didn't have to go the other side or anything like that. So I think that's a good way to get 90. There's probably another way, but we were only required to do one.
Correct. So maybe get to a different color, and
Okay.
we'll start at 3, obviously, again. So this time, Hudson, you need to get to the 70.
Uh-oh, here we go. So we got to get way over there. We know we're going to have more numbers.
And you can repeat more than just that top 3. Like if you want to go down again, you can, because there's another way to get all the way over there other than the top.
Sure. So do you want to use my strategy of working backwards a little bit? Okay, so why don't you tell us a little bit about how you would work backwards to know what you need before you get to the 70?
We have to do 13.
You have to, that's right.
Like
Definitely going to have to go through
absolutely
13.
have to. And depending on the 12 or the 30.
Well, tell me what this number here has to be, or this number right here, because then we're going to add 13 to get 70. So what do those numbers have to be?
57.
57. So we're going to put those there. Whatever you get before that, you better get 57 by the time you get here because you're going to add 13. Okay, so at least we know that we're kind of backwards one step. And we know we have to start with
3.
3. You got to start with that one. Okay, so we got those two things out of the way. Now it's just a matter of which direction do you want to go.
Let's try going to the 4.
Okay.
this time.
What's 3 plus 4?
7.
Okay, so far so good. And then there's only one way to go here, so we have to go this way. What's 7 plus 7?
7 plus 7 is 14.
14. Okay, good. So next question is, do you want to go down and over, or do you want to keep on going over, maybe over and down? I don't know. There are lots of different options here.
Well, we're at 14, and
Yeah.
we need 57, and there's
If
a
you got down to 25, it'd probably be a
right
little too
there.
much, right? Because you don't
Yeah.
want to get too high.
So I think we should keep going to the 16.
Okay, what's 14 plus 16?
30.
Good job. So we have 30 here. We're still shooting for 57. You can get a little bit of idea about what's going on there.
I think we should go down.
Okay, what's 30 plus 10?
30 plus 10 is 40.
Good for you. Okay, so far so good. Getting
Now
closer.
we need to get 17.
We do, that's right.
So you add 9 to 40, that's 49. But if you add 5 plus 9, that would be 40.
So some of the things you're thinking about here, right? 40, in order to get to 57, we need 17, right? But if you add 9, you would need 8 more. It doesn't look like we can get an 8 in there. We probably don't want to go to the 30. It's going to be too much, so the top row is kind of out. So we can go over and down and over, but then the 12 might be too much. Man, we have a lot of things to think about here. Your 17 that you were thinking about is right here, but we can't just skip over the 9. Too bad. Wish we could.
Maybe we have to backtrack.
Yeah, we might have to back up a little bit, huh? Okay, so how far do you want to go back?
Let's start by going back to the 7.
Okay, so we're here. 3 plus 4 is 7. 7 plus 7 is 14. So far, so good.
So let's try adding the 12.
Okay. What's 14 plus 12?
26.
And then we have to go.
Down to
Here.
add the 25.
And what's 26 plus 25?
51.
We're pretty high there, huh?
Yeah.
Yeah. It's okay. It's a good idea. I like that idea. See if we can go back a little bit more. We'll go back here to the 7 like you were talking about there.
So now we know that we have to go straight to the 16.
Ah, gotcha. Okay, so at least we know this part here. Okay, so what do we have? Let's see, 14 plus 16 we said was 30, right?
Yep.
Okay. Now where do you want to go? We went down before, so you probably think you're gonna have to go to the right.
Oh, I see now.
You see the path.
The 1, and then we go down to the 9.
Okay, hold on. Let's do one at a time here. 30 plus 1?
It's 31.
31. We go down to the 9. 31 plus 9?
It's 40.
40. Good for you. 40 plus 5?
45.
45. Oh, we're looking good. 45 plus 12?
57.
That's it. Nice job. Feeling good about that, right?
Nice job, because you finished that right on time, brother. Because
I like
was
it.
like, you got about 90 more seconds, and you solved it in that 90 seconds. So sometimes it might look like an easy thing to do, right? But by taking a look, and like what you guys did is kind of looked at the end of it to see where you had to end up. That's often a nice strategy to use right there.
I like that.
All right, nicely done. We'll be back with more right after this.
So you want to visit a black hole. You've packed your bags, you've updated your passport, and you're basically ready to jump on a spaceship and blast off. However, before you do that, I have just one piece of advice. Don't. Okay? If you really must go, I suppose you should at least know a few things about black holes before you leave. First, you should know exactly what a black hole is. A black hole is a physical object in space, just like everything else. It's made up of a tiny but massive point where gravity and density are infinite, a line beyond which everything, including light, can only fall into that tiny point, and sometimes some glowing stuff orbiting around it, and maybe some radiation. So basically, here is kinda bad, here is really bad, and here is safe. Also, black holes mostly come in 2 sizes. Don't ask me why, we still aren't sure. However, a black hole is also not a lot of things. It is not a hole, a cosmic vacuum cleaner, a portal to another dimension populated by unicorns and space potatoes, and absolutely not a good place to vacation. Okay, fine. I guess next you'll need to know how to find a black hole. Though technically black holes could just sneak up behind you, they likely won't. The nearest known one is 3,000 light years away anyway. However, if you were to go looking for one, there are a couple of good ways to find them. First, black holes tend to mess with their environment, so you can sometimes use interesting clues, such as a bunch of stuff orbiting what appears to be nothing. And second, as we mentioned before, there's often glowing stuff orbiting around them, caused by, well, when things get too close. So now that you've found a black hole and clearly aren't listening to me saying not to go, it's time for a few important safety considerations. First of all, the good news is that as long as you stay far away, black holes aren't all that bad. However, as you get closer, you need to keep a few things in mind. The radiation near the black hole can be extremely deadly, so the chances of escape get slimmer the closer you get. And if you get close enough, you now have to worry about being stretched into a giant noodle and time getting really weird. So, unless you have great radiation shields, a faster-than-light spaceship, or you're completely indestructible, you should probably just stay away. Well, that pretty much sums up black holes, at least before things start getting really complicated. But before you go for real, please refer to the handy brochure in your spacesuit pocket, since there's quite a bit to remember. Now then, remember your tickets, enjoy your trip, and please, be careful.
All right, a lot of stuff coming out from NASA all the time. Do you have any interest in space at all that intrigue you at all?
Yeah.
Would you go to space?
Yes, I would go to space, but only to like the moon or like the International Space Station.
Okay, so you would
No
go up
farther.
to the International Space Station?
Yeah, no
And if they go, hey, Hudson, we need you to go up there for 3 days,
I don't
you're cool with that? What about a week? A month?
Maybe.
All right, so now we got a line there. So we're like, all right,
Like a
a
lot
month
of
is
pie
the
if
line
you're going
right
for a
there, right? Yeah, they give you whatever kind of pie you want. You go cherry pie, sausage pie, pepperoni pie. If you had to eat a pizza pie, what kind of pie would you get?
Olive.
You like black olives?
Yeah, black
That's
olives.
good. My son Mickey eats black olives too on that pie like that. So next time you guys are going to get pizza, you just tell your family, go, hey, we getting pie tonight? All right, see what they say.
I like it.
You ready for a problem right now? All right, you and Scott head over to the board. Scott, you can write down any pertinent information you think you're going to need.
Okay.
All right, all of the beans and Max cups are red, yellow, or orange. 5 are red, 7 are orange. If 2/3 are yellow, how many are there altogether?
So we have a bag of, what are we talking about here? Marbles or something?
You can call them marbles if you so desire.
There's a whole bunch of them in here. And it says that there's 5 red ones. We can do that. That's pretty good. 1, 2, 3, 4, 5. And then there's, I don't even know if we have an orange. We'll make them yellow maybe. 1, 2, 3, 4.
Well, you already have
six,
yellow.
7. Oh, sorry, we have yellow. That's right. That doesn't work out very well. Hooray for erase buttons.
Here's what you can do. Here's the easy way to do it. Just put 5 R's.
Okay.
And then you can put 7 O's.
I like it. Okay.
There we go. Just another
So
way.
we have the O's. Oh, I see what you're saying. Man, this is getting way too complicated. Shouldn't have done that much. Okay. So in our bag, 1, 2, 3, 4, 5. And then we have 1, 2, 3, 4, 5, 6, 7. And then we have a bunch more in there that we don't even know about. So what do we have so far out of the 2 colors that we do know?
We have 12 marbles.
We do. So far we have 12, and then you can see them right there in the bag, right? Okay, so we have 12, and we're going to add some number that we don't know. We don't know what that is, right? And so that would be the total number that we have, right? How do you want to go about solving this problem?
I
ideas?
know that yellow is 2/3 of all the marbles. So that means 12 must be 1/3.
Oh, I like how you're doing this. Wonderful. I'll write down what you just said. 12 must be 1/3, right?
And I like how you came about that, because by doing that, you've won yourself a second problem when you're done with this one. So keep going.
A little too fast, but I like it. Good thinking. Okay, so go from there and explain what's going on there. 12 must be 1/3 because 2/3 of them are already taken up, right?
So now we need to find 2/3.
Ah, gotcha.
So we would do 12 times 2.
Okay. Can you do that for us?
12 times 2 equals 24,
Ah,
which
I like
means
it.
24 equals 2/3 or yellow.
Ah, gotcha. So the yellow ones are 24. How many total marbles do we have in this bag then?
We would have to add another third to the 24,
24. And
which
one more.
would be 12, so it would be 36.
Good deal. I like it. So 36 total, all in the whole bag, right? 24 of them are yellow, and then we already know the orange and the red ones. Man, well done. I like that a lot. Well done.
Yeah, that is well done. That's why I said I knew that you
You've
were on the
earned
right track
yourself
right
another.
there, which is why you finished that one in some great time right there.
Yep.
So because you have been working with fractions, that's why I wanted to give you another fraction problem, right? So what I'd like you to do is discuss with Scott some of the things you've been doing with fractions. So far you divided them and you multiplied them, right? So let's talk about adding fractions, but with unlike denominators. So what I'd like you to do is explain adding fractions with unlike denominators to Scott as if he was absent from school that day. You think you could do that?
Yeah.
All right, go ahead.
See what you got.
If you were adding fractions with unlike denominators, it means that the fractions don't have the same denominators.
Okay.
So if it were 1/3 plus 2/3, that's not adding with unlike denominators.
Oh, right. Because that would be pretty easy because they already have the same number on the bottom.
Yeah.
Okay, I was there for that day, so that's good.
So,
So what if you
Now-
had a different kind of problem, though?
like 5, 6 plus 3/4.
Oh, gotcha.
First, you would have to find the greatest common factor between the denominators.
Okay.
The way my teacher taught me is to play the peanut game. So do 6 and 4 and list out the multiples. 6, 12,
Oh, okay.
18, 24, and
So
list
multiples of each of the denominators. All right, I
list the
gotcha.
multiples of 4, 4, 8, 12, and then we found it. So we know that. And now what we have to do is we have to take the fractions and get them to be a different fraction that have the equal denominator of 12.
Okay.
So what we have to do is find what times this number equals 12. So 6
Gotcha.
times 2 equals 12.
Okay.
And 4 times 3. Now, my teacher taught me what's fair is fair. So what you have to do the bottom, you have to do the top.
There you go. Got to be fair to the
So-
top and the bottom. Don't want to leave that numerator out.
5 times 2 and 3 times 3. So you get 9 and 10.
Good. So the new problem that we have here now is this one, and this looks a lot more straightforward to me because it already has the same denominator in the bottom, right?
So it would be 10 twelfths plus 9 twelfths, which would be, you just add the top and and keep the bottom the same.
Ah, yeah, there you go.
So it would be, it would be 19 twelfths.
Good, there you go. Do you know how to change that to a mixed number?
So you put it to the side and turn it into a division problem, or move it all that way, and then you add a roof.
I like it. So basically what you're doing is 19 divided by 12. I
Yeah.
like that part too.
So 12 goes into 19 one time.
Okay.
1 times 12 is 12. 19 minus 12 is 7.
Good.
12 can't go into 7, so we shoot the 7 up, and it's 1 and 7 twelfths.
Gotcha. And I always try to remind my students as well, same thing, if you have that denominator in the original fraction, we want to keep that same denominator in the new fraction
Yeah.
that you have. Just kind of move that one over. The remainder is the one that goes on top.
Well
lots of
done,
fun stuff
Scott.
there.
Did you get it?
I think so, yeah.
All right.
I won't be absent again, but I like the fact that I got
There you go.
somebody to take
Absent.
notes for me.
Come on over here. So nicely done helping out the kid that was absent. Who knows what he was doing that day, but he's skipping school or something, I don't know. So you are now an ambassador for Do the Math. You know what that means?
No.
An ambassador tells people about what they represent. So if you are representing Do the Math, we have given you a uniform. You know that shirt, right? That is the official Do the Math uniform for all student guests. You must wear that probably about 18 times a month, I would say. That cool? Okay. So people are going to see you and they're going to go, hey, Hudson, what's up with that shirt? It's pretty slick looking. What's that Do the Math thing, right? You're going to be able to explain that to them, right? And you can kind of tell them when you were on, things you did and stuff like that. Are you familiar with this?
Yes.
What is it?
A Rubik's Cube.
You know how to do those?
I used to, but it's kind of slipped away. I can do a little bit.
You can do a little bit. Well, that's more than Scott or I can do together. All right? But this is an exclusive Do the Math Rubik's Cube. You haven't seen one of those before now, have you?
Nope.
Well, seeing as an ambassador, that's one of the perks of becoming an ambassador, right? You have the Do the Math Rubik's Cube. All right? So I've got a couple of questions for you because we started off the show with a couple of questions, right? So did you learn anything today?
Yes.
That's good. Did you learn more than one thing, you think?
Kind of, yeah.
Probably, right? When you look back at everything, you probably learned quite a bit of stuff today, right? So that when you were doing that simplifying before, right? That's something that you learned, right? So we learned quite a bit of stuff today. Did you have fun today?
Yes.
That's the most important thing right there. So you're now an ambassador. Tell everybody about Do the Math, and then perhaps we'll see you again. Sound good? Shake on it? Good deal, brother. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.